All right, hello math fans. We're going to do something called systems of equations today. And what a systems of equations is, basically you're trying to find out where two equations, two lines will intersect. Just to kind of start out with a basic problem, even before we get into the basics of graphing, which is what we're going to talk about today. If I give you an equation of 2x plus 3y is equal to 11, and x minus y is equal to 3. And the question is 4, 1 a solution to the following system? It's really easy. Basically what you're going to do is, we're going to do this in a little bit, but if I actually had to graph these lines, and let's just say randomly you graph one like this and the other one look like this. The solution to this equation is this point right here. Because technically this first line, or this line right here, it has an infinite number of solutions. I can point to any spot, and that any point on that line is a solution to that equation. And the same thing with this line right here. I can point to any spot on this line, and there's a solution to that equation. So there's an infinite number of solutions to each equation. But there is only one solution, this one right here, that is the same for both. And that's what we're actually going to do. So this question is 4, 1 a solution to both, or to the following system. What you're going to do is you're actually going to plug in that 4, 1, of course that being your x, y. You're going to plug it into both equations. You cannot just plug it into one, because one could have an answer right here, and that would be true, but then it would be false for the other equation. So it has to be plugged into both. It's very simple. You just plug it in. So it's going to be 2 times 4 plus 3 times 1. And does that equal 11? Well, 8 plus 3 equals 11, so 11 equals 11. Yep. So that's true, but you got to plug it into the second one. So we get 4 minus 1 is 3, so 3 equals 3. That's true, so the answer to this problem is yes. Okay, but you can't just plug it into one equation and be done with it. But it's very simple. You literally plug it into the x and the y, and you see if the left side, the left equals the right. And if it does, then the answer is yes. If it doesn't, the answer is no. It's very simple. Okay, so that's just the start of the system. Now what we're going to do is, I'm going to give you guys a bunch of equations, and we're going to graph it, and you're going to tell me whether or not it is a solution. Okay, so let's start out with a nice friendly problem here. Okay, if I give you guys let's start out with a nice little friendly problem here. If I give you a problem, y is equal to x plus 3, and y equals negative 2x plus 3. Okay, what I'm going to do is I'm going to graph this. Now you're going to be given a nice graph paper, so it's a little more difficult when you don't have any graph paper, but that's okay. We're going to graph it nonetheless. So the first one, remember, it's in the form, your equation needs to be in the form y equals mx plus b. Okay? And remember, you have your m and your b. This is your first, that's what you're going to graph first, the b, and that's your y-intercept. And your m is your slope. That's going to be your second point. Okay? So, let's start out. We got 3 as our y-intercept. We're going to plot 3. And remember, the slope is 1, so it's 1 over 1. So you go up 1 over 1. So up 1 over 1. Now what I want you to do is, I don't want you to just plot 2 points and draw the line. We have to be so exact with our points. If you plot 2 points and you draw a line, and you have the intersection happens to be really far away from those 2 points, you will not get the right answer because your line is not going to be that accurate. So what I want you guys to do is, I don't even want you to draw a line right away. I want you to just plot a whole bunch of points. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, the other way around too. I know you're like, well, geez, it's a lot of points, but you know what? This is going to give you the accurate answer. So from here, down 1 over 1, down 1 over 1, down 1 over 1. Okay, so I'm not, again, I didn't plot any points, or I didn't plot graph any lines. So the next one is this equation right here. And I'm going to go, okay, up 1, 2, 3. Well, look at that. That's very interesting. So actually, let's use a different color here. It's very interesting. I actually have a point on there that matches up right away. Okay, which is fine. But what we're going to do is we're going to plot a few more points. So it's going to be down 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1. And the other way, up 2 over 1, up 2 over 1. So my solution to this problem actually is right here. And I will ask you guys to graph it. So we're going to do that. That's only after you have the points on there. Okay, and then we'll do the black line here. But you can tell that it's not super accurate, the line, but boy, that point is really accurate. So my answer to this problem is, and remember, it's x comma y, so it's going to be 0, 1, 2, 3. That's a solution to this. That's what you're going to put on the answer blank, 0, 3. And guys, it's really easy to check it. You take this point and you plug it back into the original problem, into both the equations. Remember how I originally said, the first problem I had on here, I said, is this a solution to the following systems of equations? Well, you plugged it in. Well, this is a great way to check it. If you have time at the end of your quiz or end of your test, you need to check it. Okay, it's silly to turn it in early. You have to check your work. So again, this is x comma y. So if I plug it into this equation, y is 3 and x is 0. So 0 plus 3. So 3 equals 3. That one's good. And if I plug it into the next one, I'm going to get 3 equals negative 2 times 0 plus 3. 3 equals, that's out of there. 3 equals 3. That's true. So it's checked. Okay? It's just important to do it. I mean, why not do it if you have the time? All right, so that was actually pretty easy because that actually turned out, if you notice it, these were the y-intercepts. If the y-intercepts are the same, that's going to be your solution point. So let's do one that has a little bit more work. And it's y is equal to 1/2 x plus 2. And y equals x plus 1. So they're already solved nicely for you. So if I graph this, and let's see, I plot 2 here, and then it's up 1 over 2. So let's put a couple marks on here. You know, try to be a little neat, but you don't have to be super accurate because we're just plotting a bunch of points. So it's 2, and then it's up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2. Okay, so we got a bunch of points here. And let's plot the next one. Y equals x plus 1. So it's a 1. It's up 1 over 1. Up 1 over 1. Hey, there we go. There's our solution point. Okay, so I really don't even need to draw any more points. So I'm just going to, I still need to graph it because you have to show me that you know what you're doing with graphing. So there's that line. That's the first one. And the second one is right there. And so that coordinate is 2, 3. That's our solution. That goes in the answer blank. Again, it's really easy to check it. You plug the x and the y into there, so let's do that. 3 equals 1/2 times 2 plus 2. So 3 equals 1/2 of 2 is 1. So 3 equals 3. So that works for the first one. And we'll check the second equation. Just plug in, we have 3 equals 2 plus 1, so 3 equals 3. That works too. So that I know for sure is my solution. This guy right here, 2 comma 3. Pretty simple. Okay, so let's try a couple more. Y is equal to negative 2/3 x plus 1, and y equals negative x plus 2. Okay, so let's graph this guy here. Okay, so there's y-intercept of 1, it's down 2 over 3. So down 2 over 1, 2, 3. Down 2 over 1, 2, 3. And we can go up 2 into the left 3. Remember, it's the same thing if you go down and to the right or up and to the left. Same thing. You can see it kind of follows the pattern too, so it kind of makes sense. Okay, and let's plot the next one here. So the y-intercept is 2. Well, let's do a different color here. The y-intercept is 2. And it's going to be down 1 over 1. Down 1 over 1. Down 1 over 1. Hey, hey, right there. There's our solution. So if I graph my line, okay, and then I graph the black line. Okay, again, it's, the line is not super accurate, but boy, I counted those points, and I know that that is definitely my solution. So it's 1, 2, 3, comma, negative 1. So 3, comma, negative 1. That's a solution. Okay, and again, I can plug it back in and check it, which is a good idea. If you have a little difficulty with plugging into this fraction here, you should know how to do fractions, but you can always use your calculator. Okay, so what happens though if it's not quite set up as friendly? Let's say it's set up as 3y minus x is equal to 6, and x minus y equals negative 4. Well, a couple ways you can graph this. One is you can actually do x and y intercepts. That's really not a bad way to go. Or you can solve for y. Now, it's nice, especially when y it doesn't turn out to be a fraction for a y-intercept, because that gets a little messy. But and of course, it doesn't matter if it's a fraction for a slope because it's just rise over run. But what I want to do is I'm going to solve each of these for y. So for this guy right here, I'm going to add x to both sides. So add x to both sides. So you get 3y is equal to x plus 6, and then divide by 3. So y is equal to 1/3 x plus 2. And then this one I'm going to subtract x from both sides. So you get negative y equals negative x minus 4. Divide by negative 1. Y is equal to x plus 4. Okay, so here are your two equations, and we just go ahead and graph them. So for the first one here, the y-intercept is 2, and then let's put some points. So it's up 1 over 3, up 1 over 1, 2, 3, up 1 over 1, 2, 3, down 1 over 3. Okay, so that should be pretty reasonable. And if I do the other equation, so it's y-intercept of 4, 1, 2, 3, 4, and it's up 1 over 1. Well, you can see what's going on. If I keep going up 1 over 1, it's going to be over here. So we got to go the other way. So it's down 1 over 1, down 1 over 1, down 1 over 1. Hey, hey, right there. There it is. There's a solution. Okay, so I graph this guy right here. And graph the black line here. And my solution is going to be negative 1, 2, 3, comma, 1. Pretty straightforward. Okay, so let's try one more here. See if you guys remember a little bit about a little more graphing here. If I do 2y minus 4x is equal to negative 6, and 4y minus 2x equals 0. Okay, so once again, it's nice to be able to solve for y. Just put it in slope-intercept form. So I'm going to add 4x to both sides. So you get 2y is equal to 4x minus 6 divided by 2. Y is equal to 2x minus 3. And this one I'm going to add 2x to both sides. So you get 4y is equal to 2x. Divide by 4. Y equals 1/2 x. Okay, so let's graph these guys here. The first one, negative 3, is my y-intercept. And it's, remember, it's 2 over 1, so it's up 2 over 1. 2 over 1, up 2 over 1, up 2 over 1. And then y equals 1/2 x. The y-intercept, remember, it's 0 here. So don't get that confused. So we plot 0, and then it's up 1 over 2. Up 1 over 2. Oh, that was a really easy one. Okay, but I just want to make sure you guys understand. If it doesn't have a number there, make sure your y-intercept is at 0. So that is actually my line right here. This is the solution. And then there's your other line. So the solution is 2, 1. Okay, that's it. Okay, I have 2 more to do with you. And let's say we have an equation y equals negative 1/2 x minus 3, and y equals negative 1/2 x plus 1. So I was pretty nice to you. I gave it to you in slope-intercept form. So the only thing you have to do is graph it. Okay, so we're going to go negative 3, and it's down 1 over 2. So let's down 1 over 2, down 1 over 2. So we're out of space here, so we're going to go up 1 over 2, up 1 over 2. Okay, so we got a bunch there. And then we'll do y equals negative 1/2 x plus 1. So we have 1 here. And we go down 1 over 2, down 1 over 2, up 1 over 2. Oh man, this is not looking good. Up 1 over 2. Well, it doesn't seem like it's crossing. If I graph it real quickly, and then I graph the other one, now it's a little, not like great, but what's going on here, guys? If you notice, look at these slopes, guys. The slopes are equal. So it's the same slope. So if you think about it, if you have the same slope, what can you tell me about the lines? If it's the same slope, these lines are parallel. Which, kind of a rough sketch here, but they are. They don't touch. They are parallel. And remember when I initially taught you guys, the solution to an equation is where the two lines intersect. Where do two parallel lines intersect? They don't intersect. So the answer is no solution. Because you're asking where do they intersect? That's the solution. They don't intersect? No solution. So that's what you're going to put on the blank. Okay, that's when you graph, and you'll be able to tell that because these slopes they're the same. Okay, but we have one more to do yet, but that's important. If it's the same slope, it's parallel. Parallel lines mean no solution. All right, so let's do one last one here. 2x minus 3y is equal to 12, and 6y minus 4x equals negative 24. Okay, well, we got to solve for these guys. So let's solve for the first one. I'm going to subtract 2x from both sides. So negative 3y equals negative 2x plus 12. Divide by negative 3. So y is equal to, remember, negative over negative is a positive, so 2/3 x minus 4. Okay, that's one equation. Okay, so let's do this next one here. We're going to add 4x to both sides. So 6y is equal to 4x minus 24. Divide everything by 6. So y is equal to 2/3 x minus 4. There's the other equation. Oh, the slopes are the same, but so are the y-intercepts. In fact, these are the same equation. So what does that mean? So if I would graph this, if it's the same equation, it's down negative 4 and up 2 and over 3. They're both, if I would graph that one and then graph this one, they overlap each other. So remember again, going back to the original statement that I made at the beginning of this video, is the solution is where the two lines intersect. So where do the lines intersect? They intersect everywhere on the line. Okay, everywhere on the line. So again, it's the same equation. Now let's talk about what that is. Does that mean it's all real numbers? Actually, it's not. You cannot say all real numbers. That is actually incorrect, because all real numbers means this is a solution, and 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 this is a solution, that's what all real numbers mean. It means everywhere is a solution. Well, it's not every single number. Okay, it's not every single coordinate. But how many answers are there? Well, see the arrows on the end of these lines? It means it goes on forever. So actually, it's not all real numbers, but there is an infinite number of solutions. So the answer for this problem, and that again, if it's the same equation, the answer is infinite, and that's basically a sideways 8, infinite solutions. You can write infinite too, I don't care. Infinite solutions. Okay, but that's what that means. Do not use all real numbers. That's very bad. Okay, because it's not all real numbers. It's an infinite number of solutions, and that's what you need to put on the answer blank. Okay, so that's only if it's the same line. Right, so anyway, that's basically graphing, and hope you learned something. Hope you remembered all your graphing, and remember, plot lots of points. I don't even care so much about the line. I want to see just a lot of points. If I see 2 points on there, you're not going to get full credit for it. I want to see a bunch of points because that is going to give you the right answer. All right, math fans, have a good day. Goodbye.